So it says, find the margin of error for 90% confidence interval when the standard deviation is 50 and the sample size is 25. So confidence interval.
So we're using 90th is when you use the applet.
Yeah.
At the top you put in 0.90. And
Yeah.
so we're going to use 1.645
Yeah, that's what I got too.
as the 90th confidence interval.
You don't have to worry about the standard deviation or the...
Well, you do standard deviation divided by n times z-score.
I was just giving you the first part of the question for 90th confidence interval.
Oh, gotcha.
Square root 25.
So
Do you take the square root of the sample size? You do, right?
Yeah.
square root of the n, square root, so 5. Yeah.
So the denominator is 10.
Alpha. Sigma. There, so
Okay.
1.64.
I have my answer.
Okay, what'd you get?
16.45.
Is that rounded to 3 decimal places?
I only got 2 decimal places, so.
That looks right to me.
I'm still thinking about it here.
Okay.
The 50 divided. Anyway. So yeah, that's it. We're just taking 1.645 times 10. All right.
Awesome.
16 point. We just 3 decimal places. You just do. Do we just have 2450?
Yeah. Okay, number 4.
Which the following statement is true.
have to write a paper on that.
Yeah. What's your?
Would an X bar be a point estimator of mu, which is the population mean? I'm not too sure, but that's what I thought it would be.
Well, that sounds right, because the average, the average of all sample means is mu, and X is a sample mean. Oh, that's good. What's an interval estimated?
Interval estimator.
Range of plausible values for a parameter.
Hold on, let me see here. I'm looking it up now on the book.
Yeah, I think you're right with the X bar as point estimator of mu.
Okay.
I think when we were talking about the confidence interval, it sounds like that's the number. The X is what we're using to determine what it is, because you're either subtracting Z or adding Z to it to get the range.
Right.
So it makes sense to me that the third one would be right. C.
Okay.
Okay, number 5. Gina wants to construct a 95% confidence interval for GMAT scores. She knows that the standard deviation is 113. She collects a simple random sample size of 64 and computes sample mean of 526. Uses information for 5 through 8. What is the lower limit of this confidence interval?
So first of all, the 95th confidence, 95th percent. That's what 1.960.
Shouldn't it be 2? According to the 64, 95, 99.7 rule.
I thought we wrote in we were putting 0.95 in the top of the normal probability applet. We should get as what we're using the Z-score is 1.960.
Yeah, I see that.
So it shouldn't be 2. I think it should be 1.960.
Okay. Let's see.
And then we're using 113. N is 64. And then X
So that way, when I have leftovers,
is 526. So we're trying to figure out the lower limit of the confidence interval. So we're only going to take 526 minus 1.960.
Well,
We're not doing the plus side. We're only using the minus side, right?
yeah, for 6 we'd use the plus side.
Okay, so take square. Let's say so the calculations for 526 minus 1.960, and then we're going to take 113 and then divided by 64. So we take 113 divided by 60, the square root of 64 times whatever we get from 526 minus 1.960. That should be the answer.
13 divided by 8.
It's gonna be a bit. So multiplying that.
I was just wondering.
Oh.
So the equation is x bar minus the 1.96, and then you times that number by taking the standard deviation divided by the square root of the population.
Yes.
It's amazing how like really easy simple questions like
So yeah.
So are we dividing the it's a 14.125 from 524.04?
No, so you need to take 14.125 times by the 1.96. And then you take that number minus the, what was it?
526.
526, yeah. So 526 minus 27.685.
Okay, I did it wrong.
And I got 498.315. And then the upper limit, isn't that just the opposite, where you just
Yeah,
do
you add
plus?
correct.
Okay.
So help me make sure that I'm doing it correctly though. So we're taking the 526, subtracting the 1.96.
No.
Sorry.
No, that's your first mistake. So the first thing you need to do is find what you're going to be multiplying by, and that's found by taking the square root of the population, and then taking the standard deviation divided by that square root of the population, and then taking that product multiplied by the 196.
I see. Yeah, you have to multiply the before you subtract.
Okay, thank you.
Sarah, who is it? Sarah, who is it? So you guys find that?
So you got 498.315.
Yeah. Yep. And then for the upper limit, we just do the exact same thing. So you can save your number that you got when you take shoot, I forgot if it's 27.655 or not. Hold on, sorry.
All you have to do is take 526 plus 27.685, and then you just add another 27.685. So you're just taking 27.685 twice, and
So you should get 553.685.
Wait, what are you getting for number 6? 5?
553.685.
That's what I got too.
0.31.
Wait, what was your decimal? I got 0.54.
I got 553.685.
685. Let me redo this.
So 553.685. Yeah, that's fine.
Cool.
Oh, I did it wrong. Okay, you're right.
Awesome. So what would happen if to the width of the confidence interval if Gina increased the sample size? Wouldn't it? Let's see here. What do you think?
You increase the sample size, they should get closer together.
So the width would decrease.
Yeah.
I think yeah.
It's just similar to the example he did before with taking 50 or 100. They would what would happen to sample size? Decrease is the answer, right?
Yeah, it's decrease. And then
Same for number 8, isn't it?
yeah, it's basically the same thing, but if we changed it to a 99% confidence interval.
Yeah.
So instead of increasing the sample size, we're now increasing the confidence interval.
So that's going to change to 2.576.
And so just to kind of give us an idea using the numbers, we would do 13 divided by 8. What was the number? 99%, 2 point something?
14.125.
2.576.
Oh, sorry.
2.576. So yeah, that gives us 36.386, and so that's a bigger number. So you're gonna have a wider confidence interval.
So in other words, we're going to increase.
Mm-hmm.
That doesn't make sense to me.
That doesn't make sense.
I just have to run it through. We're just replacing the 1.960 with the 2.576. That's the only thing we're changing in the calculation.
But that changes quite a bit because it makes that number that we're adding by and subtracting by to increase, and so you're gonna have a larger range. Whereas when you change the sample size, like let's say we went from 64 to what's another perfect square, 49. We did 113 divided by 7. 60.142 times by 1.96. 31. See, that doesn't. I think that actually makes it smaller. Yeah, it's a smaller number. So we were right on the sample size. But yeah, when you increase that decimal that you multiply by, it makes that number bigger overall. And so
yeah, because we're making the smaller number smaller and the bigger number bigger.
exactly.
So it's just making the gap larger.
Yep.
Okay.
You,
So increase, 7 and 8.
so seven is decrease and 8 is increase.
Oh, sorry. Okay.
Yep. That's correct.
Wait, say that one more time. I want to make sure I did it right. 7, you did.
D is in Delta, decrease.
Okay. And
And
increase.
I is in India, increase for 8.
Okay, thank you.
Okay. So for number 9, it says Bright Bulb Light Bulb Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need? So this is using margin of error.
So we're using, he even told us I think he told us the calculation for this. N, so we're doing N equals Z, and then sigma, Z times sigma over
Sample size.
the sample size squared.
No square root of it. Yeah.
No, I think we're squaring it, not square root.
Oh, sorry, I'm looking at constant.
Okay.
I don't know if you're. We're just rearranging the. Let me just. I gotta pull up the screen we're working on. Yeah, he explained this calculation for it was number 13 in the preparation.
Yeah, I think I remember. I'm looking it up in the book right now though. Margin of error. Okay, so I did find a pretty good example here. So what does Z star mean again? When there's a star by the Z?
I don't recall.
Me neither. Because the equation is as follows: it's x bar minus Z star, and the same thing where you take Z star times. Maybe that's supposed to represent a multiplication.
Well, you still use M equals Z times sigma divided by a square root of N. So that's what we're putting underneath.
Yeah.
So I think the whole equation should be N equals Z, and then the sigma is at 0 with the thing off it. And then we're going to take that divided by alpha divided by the square root of N. It seems like you'd cancel things out. Like, why would you even have alpha in the equation? Because you have it on the denominator and the.
Yeah. Okay, so what I'm seeing here is So margin of error is m as a variable. So m is equal to the z-score multiplied by that, just the standard deviation divided by the square root of the n population.
Yes, that's what the m is.
I guess the problem is that we're trying to find n,
Yeah.
and we use a confidence interval of 95%.
Let me share my screen.
Okay.
Let's see. Yeah. I just have to share what I. Stop. Can you see?
Yep.
Yeah.
Let me maximize this. Actually, it might just be better. It doesn't make sense for me to share my screen. Let me shut this off. I was just gonna show my paper up to the. Shut this off.
So in the reading, number 5 is sample size calculations, and it gives a.
I don't know if you can see what I've written here.
Yeah, a little bit.
This is what I used in the question 13.
Okay, yeah.
Yeah.
So you basically just solve for n
Yeah.
to find that equation. Okay, yeah, let's use that equation. That makes sense to me.
Oh, they caught us, all right.
Yeah, that's in
They chased us out.
number 5 in the reading.
Is it number 5?
Yeah. Sample size
Find
calculation.
them over there. We go there, we eat some cookies like they say.
Hey guys, sorry, can you tone it down a little bit?
I just gotta plug it into the equation. So we're using 400.
For a plain yellow pumpkin to become a golden cat.
My daughter found my wife's phone.
Turn on your Bluetooth.
Yeah, anyway, yeah, she had the speaker Bluetooth to my wife's phone.
That's funny. I was wondering what that noise was.
Okay.
I guess my question on this problem is that like we don't have an X bar, like we don't have like a sample mean, and
So what's z in the equation?
don't we use that thing that we were doing before where we take 95% into the applet and we use that z-score?
Yeah.
Okay, so that's what z is, the
Yeah.
9.6.
1.96.
Yes.
Okay, z is 1.96.
But we don't have a. Do we need an X bar? Can I see that equation that he solved for n?
Okay. The problem is we need n to be able to calculate this. Just a second. Yeah, I can pull it. I'll put it in front of my screen again.
Thanks. Can you move it up a little bit? There you go. So n equals 2 times or z times sigma divided by m squared. Wait, what is m in the equation? Oh, that's margin of error. Okay.
Yes.
I'm sharing my screen where it's got it.
You have it actually. Okay.
Oh, there it is. Yeah. So what do we put in for m? I thought
Well,
we were...
m is
Right here.
m is z. Yeah. I don't know what the star means. It's the same thing. I don't. It just means multiply.
Yeah,
That's all
it's
it is.
multiply.
Z
Yeah.
is just multiply. Yeah.
That's what I was saying. I was like, I think that might be multiply. Okay, so we actually have to put in the z-score twice then, because if we substitute m in, that's going to be z times the.
Yep. Well, I'm just saying we got like I don't understand how we solve for n because m is 400. Anyway.
M is dependent on your sample size.
So what's our sample size in the question?
That's what we're trying to determine. See, M equals Z times sigma over square root of N. But N...
See, that's what I was saying, is we have M twice.
Isn't this what we're doing here?
It's the same equation, but what me and Kelly are saying is that
For the actual problem we're doing, we have to find out, because N is in the answer, but it's also in the trying to calculate it as well.
how do you do that then?
All right, let me see it so you can see it. I don't know if you can see it. Okay.
Yeah, we saw it. I saw it.
Yeah.
All right.
How do you find a variable when it's in the equation as well? I'm trying to remember back to algebra here. I can't see.
Well, we have to get it all over onto one side somehow. See, in that equation, it doesn't make sense to me why you would. I don't know. I'm going to go back to the.
Oh man. Oh guys, I figured it out. Margin of error is going to be 50. So go back to that equation where it has an M in it.
Yes.
Okay, so we're going to use that. So we're trying to find N, which is good. It's a lot.
Oh, we're just using M as the 50.
Yep, M is 50, guys. So
Okay.
we just do. So we do 1.96 times by what's our 400, and then divided by 50, and then square that. That should be our answer.
Yeah. I just don't get the question.
So 245.8624. It's going to be 245.862. Is that what you got, or you let you work it out?
Yeah, I'm finding it right now. Yep, 245.862.
So it says round to the nearest whole.
So 246.
Yeah, there was one of them we always had to go up. Like,
yep. Is
this the one where if we're rounding, we're trying to find the number of people, we always just go up to the next whole number.
Yeah, it says that in the problem in parentheses.
So 246. Round up to the next whole number, for example. Okay, 246.
Yep.
Number
246.
Okay, number 10. I think it's my turn. I don't know.
Okay.
The mean salary of actuaries is 100,000. The deviation is 36,730. You are interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it's higher or lower. You set up a hypothesis test with level of significance 0.05. You collect a simple random sample of 36 women's salaries and find that your sample mean is 111,000. Use this information 10 through 12. What is the lower limit? 95% confidence interval. Oh boy, that's going to be hard. A lot of math. Okay.
Okay.
We're not. How are we? What equation are we using? Is it? We're using alpha. Is this from the previous homework?
Yeah, you use that first, and then use the other one.
Yeah, you.
Okay, make some more paper.
I just find it easier to write things down. So are we just using this 0.05 step, plugging that into the normal probability applet to get another number to use?
No, because the 0.05 is our level of significance. So what we're going to use to plug in the applet again is going to be the confidence interval, which is 95%, so that's 1.96. And then, oh wait, yeah, we have one more variable with the level of significance.
Because we were using alpha in the other equations.
So that goes back to last week.
Level of significance. Yeah, significance wasn't even in this week's reading. I just searched it.
Wait. The level of significance, that you just use that number to, if it's higher or lower, you reject or keep the null hypothesis, right? That's all that number's for.
Yes.
Oh, that's right. What if it's bigger than, what was it?
0.05. Well, if it's bigger, you reject the truth or something. I can't remember.
Okay. Well, I mean, they're both 100,000, so that makes it easy. You don't really have to worry about it much.
So we're just using the second part of the equation to answer it, right?
Yeah. So
we're not using that alpha part really at this point.
Yeah.
No.
I think
I don't think we use that until answer 12. So
we're just gonna do the same thing where we take the x bar minus the z square. So again, that's 1.96, right? When you put 95% in.
Yes.
Okay. Yeah. So let's just work it out here real quick. Let's see. The square root of 36 is 6. So you take 36,730 divided by 6. You get some big old number, and then you take that times by 1.96. You get that number. Oh wait, but are we supposed to use mu? Because we have x bar and we have mu.
let me just.
I think we might need to use a different equation here. Let's see.
Okay.
Okay,
Well,
so the equation should be 36,730 divided by the square root of 36 times 1.96. Whatever that number is, we're going to take and subtract it from 111,000.
yep. And what I got was 99,002 for number 10, and for number 11, I got 122,998. And yeah, you just take just what we did before is the standard deviation divided by 6, square root of 36. And you take that times by 1.96. And then I just saved that number, and that number is 11,998.5, or 4.6 repeating. And then I'm guessing we just don't worry about the null or the alternative hypothesis. We're just using X bar. Because that's what the equation says. We just use X bar. We don't have to worry about mu.
Real quick, what did you get for 11?
122,998.
122,998.
Is that what you got?
No.
Dang it.
I'm starting over.
Okay.
Okay.
So just make sure, like I always take care of the hardest stuff first, like just order of operations. So you take the square root first, and then you take the standard deviation divided by 6, and then you take that number times by the 1.96, and then you just save that into your memory on your calculator, and then you take the 111,000 minus that number for number 10. And then for number 11, you do the same thing, but added to that number.
So for 10, you got 99201.
But you round up to 2, yeah.
Oh, there's a point.
So next whole, so for 10 is what's the answer?
Number 10, I got, so without rounding, I got...
I'm not getting the right thing.
I'm on board with you now. I got you.
Okay. Wait,
So,
where you lost, Jason?
So we're taking 36,730 divided by the square root of 36.
Yeah.
And then I'm multiplying that by 1.96.
Right.
Yes.
Now I'm taking that number. I think I had I think I got 11,998.4667.
Yep.
I'm subtracting that from 111,000.
Yep.
And that's the answer.
99002.
Yeah.
990.02.
02.
Yeah. No, just...
No, it's a whole number.
That's a whole number.
99,002.
Okay. I'm gonna have to. Go ahead. You can go on. I'm just making sure I got it right.
Okay. And then, what'd you get for number 11, Kelly?
I got 122,998.
Yep. That's what I got as well. And then
Wait.
Oh.
We round up, correct?
Yep. So if you...
It would be 99, right?
Always go up.
Let me make sure on that. I'm getting...
It's not. It's 122,998.46. So...
But you're always supposed to go up with...
Oh. Even if...
On to the next whole number.
This one's saying nearest.
This says nearest whole number.
Yeah.
It doesn't say go up.
Yeah, number 9 said round up to the nearest whole number. That's why I thought it was 99.
So
Yeah,
it's
you're fine.
122998 for 11,
Yep.
Yeah.
and 10 is 99002.
Yep.
Okay.
And number 12 is all the above. I read it straight out of the book.
Requirements need to be checked. For me.
3 requirements are, where is
X
it?
is normally distributed. Yes. Simple random. Yes. So if it's two of the answers, you know it's all of them.
Yeah.
So,
Yeah.
Really quick, I want to make sure I have the. What did you get on 5?
498.315.
And then 6, 553.685, right?
Correct.
yes.
Okay. I think I got them all then.
And 3 is 16.450.
Yeah. 7 is decrease, 8 is increase, number 9 is 246, number 10, 99002, and number 11, 122,988. Sorry.
Okay. I'm clicking submit, and we got.
Wow, guys, we are freaking ballers. We just got 100%, guys. Good job.
Oh my gosh, I missed number 5. I put 2 decimal places. Like 2 decimals. Dot,
Oh.
dot.
Oh my gosh.
I'll email the teacher.
Yeah, I just emailed the teacher.
Okay, that's good.
All right. Good job, guys.
Thanks for explaining that. I understand it now after this. So.
That's why we do this, huh?
Yeah, thank you.
All right. Have a good night, guys. See you Thursday.
Yeah.
Bye.